This is YouTube Joseph WM, human ancestors from the first single cell. From the first. It's the series called. Sorry, I keep getting wrong. I tried several times. Human ancestors from the origin of life to the present. To today. No, it's called human. This is human ancestors, the origin of life. Human ancestors from the origin of life to today. So we're starting as nature with the This is the episode on the dawn of life. And also, I know. Sorry, it's been a while since I did a factual series. Or anything much at all on my channel. I know a lot of you wanna. It seems like since you got my Local Historic Beast series, which is about animals that went extinct in modern times, mostly if not entirely in your recorded history, mostly if not entirely due to humans. You want to see more of that. Fortunately, that's too depressing. Anyway, mostly due to humans, those animals in this series I feature went extinct in what was historic beasts, mostly not entirely due to humans. Anyway, this series will talk about the whole evolution of humans from even before the first single cell with the building blocks of life. They were building blocks like amino acids and nucleotides. This is amino acid. I don't have enough room to show proteins because I can only show up to 8. To show nucleotides. I can show up to 8 characters. They came together forming proteins called prions, which today they're not. I don't know if there's any non-pathogenic one. They're rogue proteins that self-replicate. They're pathogenic, semi-living things. And then also let me know in the comments if it's like viruses that it's controversial whether or not they're alive. I'll look it up later. Anyway, and then anyway, moving on. So, then, so the, anyway, sorry, I got distracted. The prions in the first nucleotides, which became RNA. Some scientists think it was life began. Sorry, I'm not reading the script. And then also, life on Earth began probably 4 billion or 4.2 billion years ago. Life probably began 4 billion years ago. I'm not really sure, but it could have been wiped out several times during late heavy bombardment. If that's the case, life started at least been wiped out during late heavy bombardment. Life started at least twice independently. But that's for another video series. As asteroids and comets, we're bringing not only rocks, metals, minerals, but also water and comets bring all that in addition to organic building blocks and volatiles. Volatiles are, I think, gases like, I forget what they are. I have to look them up. They're things like hydrogen or nitrogen, and then also those other building blocks like sugar, sugar and starches, which will become carbohydrates, lipids, which will become fats. Today we're focusing on these there was the he's it was originally thought RNA based. Well, um, the RNA and the nucleotides came together to form the first RNA, which kept building a longer and longer chain and broke and kept more nucleotides kept until it was growing. Something similar happened with the earliest prions of and from amino acids. That's why. Hold on, I'm not reading the script away. If they're comments, brought the organic building. I mentioned those, and they were engulfed by a blob, probably an oily. But I forget what made up. Probably a bob, a blob of some oil, some liquid, like substance. I forget what it was. I'll research it. In the next episode, I'll leave all my sources in the description at the end of the last episode. And then to create that blob became the first cell once it engulfed the once engulfed RNA and prions and then here it was. And then also it was like, hold on, not there yet. This was the first protocell. Eventually it wasn't truly alive yet. And then also it was at least semi-living. This was I'm not sure if it was and then eventually sorry, not there yet, became this Luca, last universal common ancestor of all living things. I'm not sure if they were the same thing as the first protocells. It was a primitive oil. By this point, it had DNA and all organic compounds, like not just DNA, RNA, and proteins, but also sugar. Carbohydrates and lipids. And they life began using chemosynthesis using hydrothermal vents at the bottom of the early oceans. This is about 4 billion or 3.8 billion years ago, just right after when the late heavy bombardment, and by 3.7 billion years ago, life was underway. And then also yeah. And then and then there's no evidence. I believe these. I don't know what I was saying. This first life could have been a fourth domain. It's entirely extinct today, even though there's no evidence. That's just speculation. And Luke and its relatives, unknown relatives, belong to him. They by 3.5 billion years ago. Hold on, not there yet. Sorry. At this point, the oceans were reddish or red or they were red. The skies, the oceans were went from at one point red. There was no oxygen. Our early ancestors evolved in the first methanogen. I don't know if that's the right word. Our ancestors, which became the first Archaea, which were now Archaea, kingdom of life related to a domain related to bacteria. They're still around today, both of them, bacteria and Archaea. They were methane breathers until until cyanobacteria pumped out oxygen. Many of this happened around 2.4 billion years ago. At this point, oxygen was a poison to anything on Earth. Well, 2.5 or 2.4 billion years ago. At this point, oxygen was a poison to anything that lived on Earth, and all life breathed in methane, probably breathed out carbon dioxide. And the cyanobacteria that created these stromatolite structures, and then also sorry, just ignore noise. Became the first rock. They became the first they became the first things to breathe out oxygen. Waste product. They turned the oceans green. Sorry, just ignore the green plants. I didn't realize they were there in that scene. And then they rusted the seafloor, turned the oceans and then turned the oceans green. And rusted the in the atmosphere. And then also I forgot to mention this lightning lightning probably struck I'm not sure lightning had to do with the origin of life. That will cover a whole other series about the short series, that short 3-part short series that I did not complete that trilogy. It's out of date. The trilogy short YouTube show cover another time. Sorry, not there yet. And many of the methane breathing microbes die, but some learn to breathe it, and like our ancestors, which became oxygen breathing. Okay, actually I was wrong. Our ancestors were methanogens. They breathed out archaea. They breathed in carbon dioxide. I'm not really sure which one. Anyway, is after the oceans were rust and the atmosphere was rusted. Turned it, and the oxygen. They started a global deep freeze, which became the biggest ice age ever. Worst ice age in Earth's history ever. First snowball Earth. The cyanobacteria did. They sucked up all the carbon dioxide and converted it to oxygen using sunlight, and they also formed their own sugars. Then the carbon, all the oxygen displaced the methane. And then also which caused the planet, which was keeping the planet warm despite the sun being much dimmer than it is today. And that, coupled with the fact of lower methane and carbon dioxide levels, higher oxygen coupled with a dimmer sun, caused the planet to get colder until ice started to form at the poles, which reflected sunlight back into space, which cooled the planet even further, causing more ice to form until the entire poles, the entire planet from the poles to the equator was covered in ice from 2.4 to 2.1 billion years ago, so for 300 million years. But then life would survive in volcanoes beneath the sea. And then once the ice melted, was melted, and volcanoes, some form of volcanism, volcanic activity, it pumped out carbon dioxide that kept increasing, that melted the ice, snow, and warmed the planet back up. And by this point, appeared to 2.5 billion years ago in the Archean. Now 2.5 billion years ago, 541 million years ago is the Proterozoic. Now we're in the Proterozoic. I think no, I know that this around this time, for 2.1 billion years ago, the first eukaryote, last universal, last universal, last eukaryotic common ancestor appeared. Which were cells with internal organelles. At this point, they had, I imagine it was a combination. Our archaea ancestors were producers, probably. These ones, they were combination producers, continuous decomposers. Not really sure. There's see the cell, the yellow is the membrane. The interior, they have different organelles. Which we'll get into next time. Thank you for watching. Be sure to like, comment, subscribe as always. Bye bye.